In the classic experiment of Lavoisier, mercury 2 oxide is heated, producing mercury metal and oxygen gas. In the test tube, we have a sample of red mercury 2 oxide. We will heat the sample and it will decompose to give mercury metal, which will condense at the top of the test tube, and oxygen gas, which we will collect by the displacement of water. The mercury metal we can see as a metallic gray ring in the test tube. We can demonstrate that the gas collected is oxygen by testing the gas with a glowing splint. As the glowing splint is brought into the test tube, the combustion accelerates in the oxygen and the splint reignites.
I'm going to move it over so they can come on the hot plate.
This is reaction number 3.
Yes, Madison, good job.
Can you put it on?
Yep, Carrie needs to move over.
Oh, of course.
I'm going to,
Harder.
yeah. I just want to be able to record.
I don't want to break the glass.
It sounds very musical. Wait, are you recording this like right now so you can hear my voice?
Yes. And everybody that watches this on
Who's
Vision
gonna
will be
watch
able to hear you.
it? Just
You're
out of
posting it on
curiosity.
Vision?
Other students, because if they miss a day of the lab, that way they can at least still see the observations. I just forgot to do the first 2
Can I
reactions.
put my hand in it?
So,
Like a butterfly? Like,
no.
come.
It's a good idea.
So I have to remember for 7th block tomorrow to record the first 2 reactions. Tell Nick to remind me.
Maybe.
How long do I have to do this for?
Until it's no longer blue or green.
Oh my
or
god,
anything.
my arm's getting tired.
I'm going to jump over to a different one that's a little more further along. No, you're good.
There's no solid though.
Yes, there is. Keep going. Keep going.
There's
They're going to take too long.
Maybe it's at the
Keep going.
bottom of the glass. I don't know.
You're good.
No, she said we got
I'm only doing this so that if a student misses a day, they can go on Vision and watch the video, and then that way they still have the observations. Or like say when you go to write up like the questions, if you don't quite remember what happened, you can watch the video. I know, I do occasionally have smart ideas.
Yeah, but you missed part of the process.
Shut up. I have B-Day tomorrow.
Oh, it's green. No.
It's still a little green.
Dude, we need to slow it. I think there's something at the bottom of it, but I don't know. I'm not quite sure. That's nothing. That's right. I don't know. There might be something like at the bottom. Maybe it's not like a whole solid, just like little pieces.
All I can stare at now. It's a little awkward. Hey, Aaron. Nothing. Oh my gosh. What heat setting do you have it on? Good. Oh, it's starting to go a little more now.
I think this thing, right, around with other photos. Yeah, I don't know. Yeah,
See how it's getting more green now?
Yeah, like the front of pieces.
I'm gonna show that in the video.
Do we get it? Is it cool?
So there are hot hands on the card over. No, it's over there. Oh, they're there. You want to take it off and let it cool for a little bit? Wait, no, leave the stir rod in. You want to grab a deionized bottle. No, leave the stir rod in it. Yep. And just put that on the lab bench. And then grab a squirt bottle of deionized water. Yep. And then you'll want to squirt see all that stuff on the stir rod? You want that stuff. So squirt it down into the beaker. Okay, so far this is a 4-minute video. Yeah, see that's stuck on the stir rod?
Kind of like ash.
Yeah. So you'll want to let it cool until we can move it with our hands. So while in the meantime, you can be cleaning up all the other stuff you used. The stir rod, the beaker, all that stuff. Rinse it out really well with deionized water, dry it off, and put it back on the cart. Make sure you erase your initials on the beaker. Diala.
I'm doing it right now.
Yours is almost the same.
Yeah, so they're saying that I see you.
Huh?
Did you see you?
Yeah. The black stuff. What's the stuff on top? Mm-hmm. Good job.
Yeah, it should all. What's my pencil?
Yours is almost done.
Oh, here, I found it.
Oh. Startled me. Still slightly green. If you come down and look at it more direct on, you can see it's still a little bit green.
What do we want it to be?
See there? Yeah. It was a nice pretty blue and then got gross.
So this 4? Three. This is good.
Yeah, it's still slightly, it's almost done though.
Is this the third one?
Yep.
So that when you cool down.
You can go sit back down at your table for right now. At your seat, just make sure you bring your goggles with you because you'll need to come back here. Just let it cool. Stop touching it. Just got off a hot plate. Think about what type of reaction is this? Endo or exo? Did it require energy or did it release energy?
Line decomposition because it was on the hot plate. So is it
Good, good. You had to add heat to it to make it go. You're done.
decomposition?
You're done. Leave the stir rod in. Where'd the hot hands go?
They have it.
Hot hands? Hot hands? They don't have the hot hands. I think it might be hot. Oh, okay.
It's
Alright, and then just put it off on the lab bench.
And then we squirt the stuff.
Yeah.
Right, this
I'm gonna
is
show it
this
once
one.
more settle. Hold on, Tristan. I'll be there in a second.
Decomposition. Yeah. And that's
I'm trying to show the separation.
yeah, it's like completely separated.
Okay.
When you heat a metal carbonate, the metal carbonate decomposes to give carbon dioxide and the metal oxide. We will heat a sample of copper 2 carbonate. As we heat the copper carbonate decomposes to give a characteristic black copper oxide. The carbon dioxide that is released is bubbled through lime water. The lime water is a solution of calcium hydroxide. The carbonic acid and the calcium hydroxide react to produce calcium carbonate, which is insoluble. The lime water turns cloudy because the carbon dioxide, as it bubbles through the water, produces carbonic acid.